We have put people on the moon, landed robots on Mars, and even captured images of black holes 55 million light-years away. But if you tried to travel just 7 miles below the ocean's surface right here on Earth, you would be entering a place more alien than anything we have ever found in space. A place where the pressure would crush you instantly, where no sunlight has reached in millions of years, and where creatures that look like they were designed by a nightmare committee somehow thrive. We know more about the surface of Mars than we do about our own ocean floor. We have mapped Venus in more detail than 80% of our seafloor. And honestly, the more you learn about why that is, the more insane it becomes. So why is it that in 2025, with all our advanced technology, we still know almost nothing about the deep sea? And what is actually down there that we have not discovered yet? To understand why the deep sea is so unexplored, we first need to talk about what the deep sea actually means. Most people think of the ocean as just water, but the ocean is not one environment. It is basically stacked layers of increasingly hostile worlds. At the surface, you have the epipelagic zone, the sunlight zone, where most marine life lives. This is the part of the ocean you see in documentaries, where dolphins jump and coral reefs exist. It extends down to about 200 meters, and it is basically the only part of the ocean that is remotely friendly to humans. But once you drop below that, you enter the twilight zone, the mesopelagic. This is where sunlight starts to fade, and the temperature drops dramatically. It goes from 200 to 1,000 meters deep. Some light still penetrates here, but not enough for photosynthesis. This is where you start to see bioluminescent creatures and things that honestly should not exist, like the Humboldt squid we talked about in our other video. Below that is the midnight zone, also called the bathypelagic zone. Zero sunlight, pitch-black darkness. This extends from 1,000 to 4,000 meters, and the pressure here is already crushing. At 2,000 meters down, the pressure is about 200 times what you experience at sea level. That is enough to instantly collapse your lungs and crush your bones. This is where you find giant squids and creatures with teeth that look disturbingly human. Then there is the abyssal zone, from 4,000 to 6,000 meters. The pressure here is over 600 times atmospheric pressure. The temperature hovers just above freezing. There are no plants, barely any food, and most life moves in slow motion because energy is so scarce. This is where colossal squids and gulper eels live, creatures that look more like concepts than animals. And finally, the Hadal zone, the deepest parts of the ocean, mostly ocean trenches. This starts at 6,000 meters and goes all the way down to the Mariana Trench at nearly 11,000 meters. The pressure here is over 1,000 times atmospheric pressure. That is 8 tons per square inch. If you went down there in a regular submarine, you would be compressed into a space the size of a soda can before you could even process what was happening. And yet, life still exists down there. Weird, alien, barely recognizable life, but life nonetheless. So, why do we not just explore it? Why cannot we just send submarines down there like we send rockets into space? The thing is, exploring the deep ocean is much harder than exploring space. It sounds surprising, but it is true. In space, the main challenge is getting there. Once you are in orbit, there is no pressure and there is no resistance. You are in a vacuum. Your spacecraft can be relatively lightweight because nothing is actively trying to crush it. A space station can have walls that are a few centimeters thick and be perfectly fine. But in the deep ocean, every meter you descend increases pressure. At the bottom of the Mariana Trench, you face pressures that would instantly destroy almost anything we can build. To survive there, a vessel needs walls that are incredibly thick, made of specialized materials. The Titan submersible that imploded in 2023 was not even attempting to reach the deepest parts of the ocean. It was going to the Titanic wreck at about 3,800 meters, and it still catastrophically failed because of the pressure. The people inside were compressed so fast that their nervous systems did not have time to register what was happening. Only a few vessels can reach the Hadal Zone, and they are engineering marvels. The Deep-Sea Challenger, which James Cameron used to reach the bottom of the Mariana Trench in 2012, had a cruise sphere that was only 43 inches in diameter. That is barely enough space for one person. The walls of that sphere were 2.5 inches thick, made of specialized steel foam. The whole craft weighed 11 tons, just to keep one person alive for a few hours. Compare that to the International Space Station, which is massive and can support multiple people for months, while its walls are much thinner. And here is the other problem: communication. In space, we can communicate with spacecraft using radio waves. It is not perfect, but it works. There is a delay because of distance, yet signals travel at the speed of light. In the ocean, radio waves do not work underwater. They get absorbed almost instantly. To talk with deep-sea submarines, we have to use acoustic signals. Sound is much slower and much less reliable. Sometimes contact is lost entirely. It is like trying to have a conversation while yelling through a mattress. That is why when deep-sea explorers go down, they are often essentially on their own. If something goes wrong, getting help in time is very difficult. Then, there is the issue of power. In space, solar panels work well. The sun is effectively always available, and spacecraft can harvest solar energy for long periods. In the deep ocean, there is no sunlight, so solar panels are useless. You must bring all your power with you, which means batteries. Batteries add weight, and that requires more structural reinforcement to withstand pressure. It becomes a vicious cycle. Every kilogram of equipment you bring requires more reinforcement, which adds more weight, and that requires more power. Missions to the deep sea are often limited to hours, sometimes just minutes, because of power constraints. Meanwhile, rovers on Mars have lasted for years. And then there is visibility. In space, once you are past Earth's atmosphere, you can see extraordinarily far. Telescopes can peer billions of light-years away. In the deep ocean, visibility is measured in meters, sometimes in centimeters. The water is full of particles, sediment, and organic matter. Even with powerful lights, you can only see a few meters ahead. It is like exploring a planet while wearing a blindfold, and you can only take that blindfold off for a few seconds at a time in random spots. You might pass right by something incredible and never even know it was there. This is why we have explored such a tiny fraction of the ocean. We have mapped about 20% of the seafloor using sonar, but that is just mapping the shape of the ground. That is like looking at Earth from space and saying you have explored the planet because you can see the continents. Actual exploration, where humans or robots go down and look around, see what is there, study the creatures, and take samples, we have done that for less than 5% of the ocean. Some estimates put it even lower, at around 0.05%. We have physically visited more of the moon's surface than we have of our own ocean floor. And when we do explore, we find things that completely defy our understanding of biology. In 1977, scientists discovered hydrothermal vents on the ocean floor, underwater geysers that spew out water heated to 400 degrees Celsius. And around these vents, they found entire ecosystems that do not rely on sunlight at all. They are powered by chemosynthesis, where bacteria convert chemicals from the vents into energy. This was a paradigm shift in biology, because up until then, everyone assumed that all life on Earth ultimately depended on the sun. But these creatures do not. They live in complete darkness, in scalding water, surrounded by toxic chemicals, and they thrive. There are giant tube worms, white crabs, and eyeless shrimp that have light-sensing organs on their backs. Then there is the discovery of the colossal squid in 2007. Scientists had known it existed because of beaks found in whale stomachs, but no one had ever seen a full adult specimen. When they finally caught one, it weighed over 1,000 pounds and had eyes the size of dinner plates. And we still barely know anything about them. How long do they live? How do they reproduce? How many are there? No clue. We have only ever found a handful of specimens. Or take the Mariana snailfish, discovered in 2017. It lives at depths of 8,000 meters, which is deeper than anyone thought fish could survive. Fish have swim bladders filled with gas to help them control buoyancy. But at those pressures, gas compresses so much that swim bladders would be useless. So how does the snailfish do it? It turns out it does not have a swim bladder. Its body is mostly water and gelatinous tissue, which does not compress. It is basically a living blob that is perfectly adapted to pressures that would liquefy most other fish. But the most disturbing discoveries are the things we have only seen once or twice and cannot explain. The bloop, for example. In 1997, underwater microphones picked up an extremely loud, ultra-low frequency sound from the South Pacific. It was so loud that it was detected on sensors over 5,000 kilometers apart. People speculated it might be some unknown massive creature, bigger than a blue whale. It turns out it was probably just an iceberg fracturing, but for a while, nobody knew. And the fact that we could not immediately identify it shows how little we know about what is making noise down there. Or the big fin squid, which we mentioned in the squid video. We have only ever seen them on grainy deep-sea camera footage. They look like something out of a horror movie, with arms that are 4 times the length of their body, and elbows that bend at unnatural angles. We have never caught one. We have never studied one up close. We do not know how big they can get. We do not know what they eat. We just know they exist, and that is terrifying. And here is the thing. The deep sea is not just full of weird creatures. It is also full of things we need. Rare earth minerals, which are essential for smartphones, electric cars, and renewable energy technology, are abundant on the ocean floor. There are entire fields of polymetallic nodules, potato-sized rocks rich in cobalt, nickel, and manganese, sitting on the seafloor waiting to be harvested. But we cannot mine them efficiently yet because the pressure, the darkness, and the technical challenges are extreme. Some scientists estimate there could be more gold in the ocean than has ever been mined on land. It is dissolved in seawater, not in high enough concentrations to extract economically yet, but it is there. The ocean floor also has massive reserves of methane hydrates, a potential energy source. But if we are not careful and destabilize them, they could release huge amounts of methane into the atmosphere, which would accelerate climate change catastrophically. And then there is the issue of undiscovered species. Scientists estimate that up to 2/3 of marine species are still unknown to us. 2/3. That means for every weird deep-sea creature we have found, there are 2 more we have not, and some of them might be huge. The ocean is big enough to hide things the size of whales or bigger. Sperm whales dive to 2,000 meters to hunt giant squids, and even they do not go to the deepest parts. What is down there that even sperm whales avoid? There is also the possibility of undiscovered ecosystems. Hydrothermal vents were only discovered in the 1970s, and they fundamentally changed our understanding of life. What else is down there? Are there underwater lakes of brine, separated from the ocean by differences in density? Yes, those exist. They are called brine pools, and they are so salty that they do not mix with the surrounding water. They have their own shorelines, underwater, and anything that swims into them usually dies because the salinity is toxic. Some creatures have adapted to live near them, feeding on the corpses of things that wander in. It is basically an underwater death trap, and we only found out about them in the 1990s. Or underwater rivers. Yes, those exist too. On the ocean floor, denser water can flow like a river beneath lighter water. One of them, found under the Black Sea, would be the 6th largest river on Earth if it were on land. We only discovered it in 2010. The point is, the deep ocean is full of things that should not exist, that we did not think were possible, and that we have only stumbled upon by accident. And we have barely scratched the surface. Meanwhile, we are planning manned missions to Mars, building telescopes to look at exoplanets, and mapping the cosmic microwave background radiation from the Big Bang. All of that is incredible, but it is kind of absurd that we know more about the surface of Mars, a planet 140 million miles away, than we do about the seafloor right here on Earth. Part of the reason for this is funding. Space exploration is sexy. It captures the imagination. People dream of going to space, of colonizing other planets, of finding alien life. The ocean? It is just water. It is here. It is not exotic. But the ocean is where most of life on Earth actually lives. It produces over 50% of the oxygen we breathe, regulates the climate, and feeds billions of people. And we are destroying it without even understanding what is there. Ocean acidification, plastic pollution, overfishing, these are all massive problems, and we are trying to solve them while being almost completely ignorant of how the ocean actually works. We do not know how many fish are down there. We do not know how deep-sea ecosystems respond to changes in temperature or chemistry. We are flying blind, and the consequences could be catastrophic. But there is hope. Technology is improving. Autonomous underwater vehicles are getting better, cheaper, and more capable. We are developing new materials that can withstand extreme pressure. Sonar mapping is getting more detailed. In the next few decades, we might finally start to explore the ocean the way we have explored space. And when we do, we are going to find things that blow our minds. Because if there is one thing we have learned from the small fraction of the ocean we have explored, it is this. The deep sea does not follow the rules. It is a place where the impossible happens routinely, where evolution has created things so strange that they seem like they belong on another planet. And the scariest part? We have barely even looked. So the next time someone talks about the mystery of space, about the search for alien life, about the final frontier, just remember, we have our own alien world right here. It is 7 miles down, it is full of nightmares, and we have ignored it for decades. Maybe it is time we actually paid attention. If you want to see more about the weird creatures living down there, watch our videos on squids and eels. Thanks for watching.